Let us now go to the last part of this module. So for today, we will talk about borrowing. Okay, so there are two kinds of people, of persons. So you have, of course, the lender or creditor, the one who loans money. And of course, you have your borrower, the one who borrows money. Okay, let's talk about first borrowing with one-time payment. So if you can still remember, we have two kinds of interest, your simple interest and compound interest, right? We talked about these two kinds of interest in the first part of this module when we talked about savings account. Okay, so here are the formulas again for simple interest and compound interest. So the formula that is given here, R over M is like your rate per period, right? And then M times T is the number of periods. Okay, let's look at this example. On November 20, 2019, Ellen borrowed 36,500 from Elmer. She promised to pay the principal and 11.75% simple interest on May 9, 2020. How much will Elmer receive on the said date? So, what will be the future value? It's just the principal plus the interest, right? So this is 36,500 times 1 plus the rate is, what is the rate? 11.75, 0.1175. But what is the time? So November 20 to May 2020. All right, so what is that? From November, okay, we really have to get the exact number of dates because for the time, we will turn it to number of days, correct? Over 365, right? So let us count that. So from November 20 to 30, how many days is that? That's 11. And then December, January, February, March, April, and then May, 1 to 9. Okay, so December has 31, 31, 28. March has 31, and then April 30, and then May 1 to 9, that's 9 days. Correct? So therefore, that's how many days is that? So that is 171 days. So therefore, that's 171 over 365. Okay. So therefore, what is that? 0.1175 times 171 divided by 365 plus 1 times 36,500. I get 38,509.25. Okay? Okay, we have this problem. A lending institution charges its client 1,008,000 on a loan of 1.6 million for 5 years and 3 months. What simple interest is applied? Note that this 1,008,000 is already the interest because it says that the lending institution charges, correct? Meaning to say, the borrower will pay 1.6 million plus 1,008,000 after 5 years and 3 months. Is that clear? Okay. What is our interest? That's PRT. So that's 1.6 million times R. What is our time? Our time is 5 years and 3 months. But 3 months is 3 over 12 of a year, or 5 and 1/4. Of course, we have to turn that into mixed form. So that's 21 over 4. Okay? So this is, their interest is 1,008,000. Okay? So let us divide first by 1.6 million. So we get 21 R over 4 is, that's 0.63. Since we're solving for R and R is multiplied with 21 over 4, I will just multiply both sides by the reciprocal. So that's times 4 divided by 21. So therefore, your R is 0.12 in percent form. That is 12%. Next example, on April 15, 2013, Justin borrowed 1.4 million. He agreed to pay the principal and interest at 8% compounded semi-annually. How much will he pay then? So therefore, we're looking for the future value, right? And the formula is this. So let's plug in our principal amount is the amount of the loan, 1.4 million. 1 plus your rate is 8%, but compounded semi-annually. And then raised to 2 times, what is this? April 15 to July 15, 2018. That is 5 years and 3 months as well. So that's 21 over 4 years. Alright, so let's now use our calculator. 1.04, you raise it to 21 over 2 times 1,400,000. So the answer is, this is 2,113,382.458. So it's big because, of course, um, the interest is big. 8 million. I mean 8 million. I mean 8%. Okay? Okay, next example. As debt payment, 315,000 is due in 4 years and 7 months. If the debtor wishes to repay the debt now, and the lender applies 9% interest compounded semi-annually, how much does he have to pay? Okay, so this means that this 315,000 here is your future value. In 4 years and 7 months, you have to pay 315,000. Meaning to say, how much is, because it says that he wants to pay now. This is what you call your future value. And what we're looking for is the present value. Okay? So, what is the formula? Future value, right? So, our formula is still the same. P times 1 plus R over M raised to MT. So let's plug in 315,000 is equal to, we do not know the present value, 1 plus 0.09 over 2 raised to 2 times, this is 4 and 7 over 12, correct? Or 55 over 12. Let us simplify this. So I have 315,000 is equal to P times 1 plus 0.045, that's 0.09, divided by 2 raised to 55 over 6. What is that? That's approximately 1.497. Okay, so our principal therefore is 315,000 over 1.497. So 315,000 divided by, you can just use answer in your calculator. Okay, so that's 210,415.5789. Okay, so that's how you compute. So this is actually problems that arises when, for example, I have a debt, something like that. Okay, and then I want to pay in full now. Okay, so this is really useful. All right, so you can pause your video and try to answer this exercise. Assuming that you have paused your video, take note that this is just the same as the previous example, right? Although this is not borrowing, but the point is, you want to have 125,000 after 6 years. You want to know how much money should you invest. Now, there is actually no difference between borrowing and investing. Correct? What happens lang when you're the one who is investing, you are lending money to the bank. You're lending money to the bank. Whereas if you borrow, of course, the bank lends money to you. So that's why it's just the same. All right? So again, so what is this? The future value is equal to the present, which we do not know, 1 plus R over M, 10% compounded quarterly. So over 4 raised to 4 times 6. Okay. Actually, what you can do, you can just divide by this whole thing, star. Okay. So that when you use your scientific calculator over star. Wait, let me see. So that's 125,000 divided by 1 plus 0.10 over 4 raised to 24. So you get P is equal to 69,109.42 approximately. All right? Okay, so here's another exercise for you. On July 12, 2019, Veronica borrowed 100,000 and agreed to pay the interest at 7% compounded monthly. How much must she pay if she wanted to discharge this debt on April 12, 2020? Mhm. So therefore, what are we looking at? We're looking for the future value, right? This is July 12, 2019. We are looking at the future value on 4/12/2020. What is now the value of 100,000 at that time? So future value is P 1 plus R over MMT. Present value is 100,000 times 1 plus rate is 7% but compounded monthly. Then 12 times, what is that? July, how many months is that? July, August, September, October, November, December, January, February, March, April. This is 9 months. So that's 9 out of 12 months or 3/4 of a year. Correct? So this becomes 3. So we just now use our calculator. 1 plus 0.07 over 12 raised to, what's that? Raised to 9 times 100, 123. So that will be equal to 100,526.23. Okay? We will now talk about wherein you will pay your debt via several regular payments. An annuity. We are now talking about an annuity. An annuity is a sequence of equal payments made at equal intervals. The amount of each payment is referred to as the regular payment and it is denoted by R. Okay, so let's look at some formulas. Again, what is happening in this scenario is that you are paying regular payments. Okay, and then you want to know, including interest, right? You want to know what will be the future value of all these payments at a certain time. Okay? So take note that this F here is the sum of all periodic payments made at the end of each term plus the compound interest. So the formula is given by that, wherein of course F is the future value, R is your regular payment, and then you still have your J, that's the rate, and then M is still the number of periods per year, and of course T is this is still time in years. Okay, so let's look at this example. 10,000 is deposited annually for 3 years with an annual interest rate of 3%. How much will be in the fund at the end of 3 years? I want to illustrate what is happening here. Before using any formula, I want you to understand, okay? When we say we want to get the future value, we want to get the value of your investment at this point, at the end of 3 years. So first, your 10,000 invested at the end of the first year, it will earn interest, right? So that's 10,000 times 1 plus 0.03, which is your rate, raised to 2, correct? I'm just using the formula for compound interest, correct? But since it's just compounded annually, so your M is 1. Next, for your second 10,000, you invested it only for 1 year. And of course, lastly, your 10,000 here. Okay, so we want now to add all of this. So what is 10,000? 1.03 squared times 10,000 is 10,609. This is 10,000. 1.03 times 10,000 is 10,300. And then, of course, your 10,000. So when you add that, what is that equal to? That's 30,909. That is now the value of your investment together with the interest. Meaning to say your total investment was 30,000, but you earned an interest of 909. Okay? Okay, so what now if we want to find the present value? This is the formula. So it's a bit different. Remember what is the formula for the future value? 1 plus j. It's just that they are interchange, right? But this one, it starts with 1 minus. And of course, the exponent here, instead of empty, you get the negative of that. Understand? Okay, so let's look at this example here. A smartphone is purchased with a down payment of 1,000 and the balance will be paid at 1,075.83 a month for 1 year. What is its cash price if the interest rate is 6% compounded monthly? So I want to illustrate what is happening here. So at time 0, present, you have a total, you have down payment of 1,000. Okay? And then at the end of each month until 12, you will pay 1,075.83. Okay? And so on. What is its cash price if the interest rate is 6% compounded annually? So what we want to know is to get the value of all of this at time 0. So that's why we're looking for the present value. But first, what we will do is this one. We will get the present value of the regular payments. Is that clear? Okay. So, what is the present value of your annuity of your 1,075.83? All right. So, what is our formula? Our P is R. What is my R? 1075.833. 1 minus 1 plus interest is 0.06 over 12 raised to negative 12, right? Because it's only for a year. 12 times t, but t is 1. All over, oops, the entire thing, all over j over m. So 0.06 over 12. Wow, that is big. Okay, so let us now use our calculator. Wait. All right. So upon doing that, you will end up with 12,500. Okay? So that is the present value of your annuities. But remember that at that time, you paid 1,000 as down payment. So therefore, what is the cash price? The answer is 12,500 plus your 1,000, which is 13,500. Is that clear? So meaning to say, the original price was 13,500, but you already paid 1,000 here, right? So that's why your loan na lang is 12,500, and you paid off your 12,500 loan through your series of regular payments of 1,075.83. Is that clear? All right, so suppose we want to get the regular payment. Okay, so that formula is given by this. Actually, you don't need to memorize this because it actually just came from your previous formula for the present value. Correct? From here, if you know the present value, you know all of this, you just divide the present value by this thing. Or it depends if you were given naman the future value and then you want to get the regular payment. You just use the future value formula because that's what you're given and then solve for R. Alright, so let's now find the monthly amortization for a 150,000 debt, which is to be repaid in 2 years at 7% compounded monthly. Now, take note that we can simplify this formula because it is a complex fraction, right? The form is like A all over B over C. And how do you divide fractions? A times division becomes multiplication and then get the reciprocal. So therefore, our R becomes P and then division becomes multiplication and then get the reciprocal of this one. So you just interchange the numerator and the denominator. Okay, I will now erase this. Okay. Let us now plug in. So my original debt, my P, 150,000 times 0.07 over 12 all over 1 minus 1. My J is 3%. I'm sorry, 7% over 12 raised to negative 12 times 2 monthly for 2 years. Let us now use our calculator. 150,000 times 0.07 divided by 12 is 875. We now divide that by 1 minus 1 plus, oops, 1 plus quantity 0.07 over 12. What's next? Raised to negative 24. There you go. So the answer is 6,715.89. Alright? Okay, here's another example. A housewife buys a pair of earrings worth 20,000. She pays 5,000 and the balance on semi-annual installments for 2 years. If the interest rate is 4.5%, find the semi-annual payment. Alright, so I have here the formula for your R. Okay, and then let's just plug in my present value is 20,000 and then 0.045 over m, which is 2 because that's semi-annual, all over 1 minus 1 plus 0.045 all over 2 raised to negative 2 times, how many years is this? 2 years. Okay, so let us compute 20,000 times 0.045 divided by 2. That is 450. That answer, you divide it by 1 minus 1 plus 0.045 over 2 quantity raised to negative 4. The answer is 5,284.38. Okay. So that means how much interest did she pay? Because she paid, this is, what was her total payment? Total payment was, you have four payments of 5,284.38, right? 5,284.38 times 4. So she paid a total of 21,137.52. So the interest that she paid was 1,137.52. Okay? Alright, so let's look at this nice problem over here. This is actually like a case of which one is better, investing early or investing regularly? Although in our previous video lessons, I told you that you should invest early and regularly. But if you are given the choice between, you just have to choose one of the two, invest early or invest regularly. What would be the good decision here? So let's look at this scenario. Both Alice and Bob invested their money at the bank at 7% annual rate on their retirement funds. So they are saving for their retirement. The only difference is when and how often they save. Okay, so Alice invests $5,000 per year beginning at age 18. At age 28, she stops. So she only has one time payment at age 28. All right. And then we want to know how much will be um, how much money will they have at age, let's say, 65. So this is for Alice. Whereas for Bob, invest the same 5,000, but oh, I'm sorry, Alice invested when she was only 18, but for Bob, he invested at age 28. All right, and then at age 28, he invested. All right, so let's just say, okay, anyway, so this is 5,000 and it's always 5K. 5K. All right. So who has more money when they reach their retirement age? What do you think? All right, so I have here the scenario. So here, Alice invests um, at age 18 and then she stops at age 20. So these are her annual payments of 25,000 and this is for Bob, 25,000 starting at age 28 until age 57, and then he stopped. So we want to know what would be their money by age 58. So assuming that they will both retire by age 28. So take note here, this is the total investment of Alice. Yeah, for Alice because 25,000 for 10 years, and then this is for Bob. Okay. So let us compute the of course at age 18 Alice has 25,000, and then it will start to accumulate interest, right? So this one will be multiplied by 1.07, and then we will add her additional investment. And then just like in our examples of investing early, right? The only exception is that the 25,000 will end. Okay? It only ended here. So that's why when you have it here plus C14, that is already empty because Alice already stopped investing that year. So this means that she has a total, her balance, her money, the value of her money is now 2,813,000. Let's also do that for Bob. Then this one is previous times 1.07, assuming that the interest rate is 7%, then plus additional investment. Okay? And then go down. How much is it? So as you can see, okay, so what happened here? As you can see, even though Bob's total investment was 750,000, whereas for Alice it's only 250,000, when they reach age 58, Alice has more money than Bob. All right, so amazing, right? So that is really the power of compound interest. Let us compute the return on investment. So what do you do? The profit, right? This minus her total investment and then divided by the cost, which is again C46. So C, Alice has 1,025.37% on her investment, whereas for Bob, let's do that again. Oops. So that's this minus total investment over the investment. So he only realized 236.91%. All right, whereas this one is really 1,025.37. So the early bird, anong sabi nila, daig ng maagap ang masipag. So Alice is an example of an early bird when it comes to investment. So it's really true that you don't have to work hard. You have to work smart. All right? So use your money to make more money. All right, so let us now talk about amortization. What is the meaning of an amortization? It is a process of settling a loan into a series of fixed payments over time. Of course, when you are paying your debt, when you have an amortization, you also have what you call an amortization schedule, or a table showing how your debt will be completely repaid through your periodic payments, parts of which go to interest payment and principal repayment. Alright, so let's look at this example. You have a 65,000 loan at 12% interest. Compounded semi-annually is to be amortized every 6 months for 3 years. Find the semi-annual payment and construct an amortization schedule. Of course, you cannot find an amortization schedule if you do not find the regular payment. Okay? So what is now the formula again for your R? If you can recall, that is equal to P times R over M all over 1 minus 1 plus R over M raised to negative MT. P is the present value or the original, the amount of loan. So that's 65,000 times interest is 0.12 but compounded semi-annually, so over 2. All over 1 minus 1 plus again 0.12 over 2 raised to negative RM is 2, RT is 3 years. Or meaning to say we have a total of 6 periods, right? So when we use our calculator, you will end up with 13,218.57. This is your regular payment R. Alright, so I have here my amortization schedule. You always have your period column, your periodic payment, and your interest. This part here goes to interest payments and then principal and then your outstanding balance so that you know how much money you still owe by the end of that period. Okay, so we know that our periodic payment is, it starts on period 1, right? So 13,218.57. Okay. And then what will happen? Remember that the first period means this is after 6 months. And recall that we have 12% compounded semi-annually. Effectively, that just means that you have 6%, right? 6% per period. And your period is 6 months. All right. So how much is the interest for the first period? So it's 65,000 times, oops, times, you get 6% of that. Okay. So that means for the first period, the interest for your loan is 3,900. But you paid 13,218.57. So that means how much will be paid to your principal or your original loan. So that's 13,000 minus the interest. Oops. Okay, let me just delete that. Okay. Again, I just want to repeat that. Where did I get this? It's equal to your periodic payment minus your interest so that this total would be equal to your periodic payment. How much is now your outstanding balance? You will now deduct 9,318.57 from your original loan. So it's this minus this. Okay. And then we will just drag them down the entire. There you go. So as you can see, again, let's just look at this one. What is this? This is 6% of the previous balance, correct? And then how do you get the principal? It's equal to your periodic payment minus the interest, right? So as you can see, class, from the table, in any amortization, yung first few periods mo, mataas ang binabayaran mo sa interest. Okay? And then as time goes by, more part of your payments will now go to your principal payment. Okay? All right, so let's look at these exercises again, please pause your video and try to answer the following. Okay, assuming that you have already paused your video, let us now discuss. Mrs. Martin purchased a condominium unit and agrees to pay 200,000 cash and 40,000 every 3 months for 5 years. What is the cash price of the condominium unit if money is worth 10.75% compounded quarterly? All right, so as you can see, this is the interest rate, right? Compounded quarterly, and her payments are also quarterly. All right, so remember that in our formula, the the compounding period should be the same as the period for your payments. All right. Anyway, so let us now compute. Wait. So let's have a table. So anyway, so this is 0. This represents the number of years, 3, 4, and 5. And of course, each of these are divided into 4 parts. Anyway, we just know that anyway, just so that you can imagine. Okay. She paid 200,000 here at present as down payment. And then for each period, every 3 months, she will pay 40K. All right. And so on until here. What is the cash price? So this is a bit similar to what we had earlier. So what will we do first? We will get the present value of your regular payments, right? And what is our formula again? The present value. Again, what does that mean? It means that I'm getting all of this, I'm putting them here at present. Okay, I want to find their value. Okay, so what is the formula? Our formula is R times 1 minus quantity 1 plus R over M negative MD all over R over M. So that's P is equal to, what is that? 40,000, 40K. 1 minus 1 plus 0.1075 over 4 raised to negative 4 times 5 all over wait, I have a parenthesis here. All over 0.1075 over 4. Okay? Alright, so from our calculator, we get 612,662.91. But this is the present value again of regular payments. But you still have to add your 200,000 down payment, correct? So the answer is 812,662.91. Okay, try this next exercise. Pause your video again and answer. Assuming that you have paused your video, let us now discuss. Carl borrows 200,000 and agrees to pay the principal and interest by making equal payments at the end of every 6 months for 4 years. Find his semi-annual payments if the lender charges 12% compounded semi-annually. So this is just a matter of looking for your regular payment. So I'm writing down the formula. Negative empty. Okay, so that's 200,000 0.12 over 2 all over 1 minus 1 plus 0.12 over 2 raised to my m is 2 times 4. So when you use your calculator, you will end up with 32,207.19. Now let's talk about credit cards. Most people they look at credit cards as if it's for free, right? So you have to be very they just swipe and swipe and swipe because it's just charged to their credit card. But remember that you have to be very, very responsible when it comes to credit cards. Otherwise, you will end up in deep debt. Okay? Don't allow yourself na mabaon sa utang. So that's why this course is here also to help you become responsible with credit cards. So to become responsible with your credit card, you have to know first the fees that you will be charged when you use your card. Okay, so for the first one, you have, of course, your annual fee. It depends on the type of card that you have, but they usually range from 600 to 5,000. And of course, you have cash advance fee. Meaning to say, you can like withdraw money from your credit card. But this one, when you have cash advance fee, the interest is really high. So you can see as if, okay, it's just 1% to 6%. That's okay. But remember that compound interest is very powerful. Don't be fooled by the small numbers that they show you. And of course, you have late payment fees. You also have that. If you do not pay at all, you will be charged a late payment fee ranging from 3.9% to 7.5%. You also have excess limit fee. So meaning to say, suppose you only have, in Citibank, they call it relationship balance. Let's say that's only 25,000, but you exceeded, all right? So you will also be charged for that. And of course, if you lose your credit card, you have a card replacement fee. Usually the range is 400. Okay, next. Interest on outstanding balance. This is 1% to 5% per month. Meaning to say, if you do not pay the full amount, all right, you will be charged. Again, it depends on the type of card that you have, but the range is 1% to 5% per month. You also have transaction fee, but for the transaction fee, this is actually charged to the merchant. So that's why not all companies, you still have to ask if they accept credit cards, right? Because they also get charged, all right? So for example, I buy something at Landmark, the cost is 1,000 pesos. All right. So it depends on the bank and their use of they have like this machine, right? So when they use that machine, they have an agreement with the credit card company that, okay, for every card swipe here, you will be charged 3.5%. Okay? So if they sell something 1,000 pesos, 3.5% will go to the credit card company. Okay? So that's why you're familiar with if you're buying appliances. So for example, they will say, all right, so the price is 24,500 and then 0% interest, which is good. That's a nice deal. 0% interest for and then payable for 6 months. But they also have this, but if you pay in cash, they give something like 20, it's only for 21,000. They give you a better offer. So the reason behind that is if you pay by cash, they will get the 21,000 pesos whole, walang bawas, because you did not use your credit card. Understand? So, but for me, actually, I take this deal as long as it's 0%. I don't mind my savings here. If I really don't have the money at that time, I would rather pay it in 6 months, but at least 0%. If it's not 0%, I don't take the deal. Anyway, other fees, we will take a look at that in the example. All right, so I have here city card fees and charges. Um, okay, so first, here you have your annual membership fee. So it depends, all right? So the highest is for the gold 2,500, and of course if you have a supplementary card you also have to pay their membership fee. What is the meaning of a supplementary card? So for example, I have a card and then I want to get a supplementary card for my husband. My husband does not need to apply for a credit card because although that card is under his name, the card will have his name on it, but when the billing comes, it will all be charged to the principal account. All right. Next, you have your retail monthly effective interest rate. Now, what does this mean, class? You when you see this 3.5%, it's okay, right? But remember, this actually means 3.5% per month. So if your period is month, what is this equivalently when you have annual? So that's 3.5 times 12, correct? So annually, this means 42% compounded monthly. So it's really high. Actually, the Philippines is one of the countries with very high interest rates when it comes to credit cards. Of course, they will just show you the 3.5%, but annually, it means it's really 42% compounded semi-annually. And also, if you take a look at this one, you even have bigger interest rate when you use cash advance. All right. And then aside from the interest rate of cash advance, you also have another charge, service charge if you use cash advance, 500 or 3% of your cash advance amount, whichever is higher. And then again, if you fail to pay, you get a charge of 850, or if your charge is less than 850, that will be the late charge. Okay, and then of course you have here your minimum amount due and so on. And also if you use your card outside of the country, take note here. Actually, I did not read this before. I just used my credit card, but actually it's not a good idea to use it abroad. Why? If you do not use it in the US, here, for transactions in foreign currencies other than US dollar, the amount will first be converted to US dollar before being converted to its Philippine peso equivalent. All right, and you also have a fee of up to 3.525%. This one will be imposed on the converted amount, which represents our service fee and assessment fees charged by Visa MasterCard. So that is a lot. All right, and you all know, I don't know if you don't know, if you know that, but actually when you have money and then you keep on what's this, converting it from one, just like what happened here. For example, you go to Singapore. So you have Singapore dollars. You bought something. It will be converted first to US dollar, right? And then to Philippine peso. So ang dami mong dinaanan, lugi ka dyan. And aside pa from your 3.5 to 5%. So meaning to say, if you will go abroad and you want to buy something, it's better to pay in cash. If you don't have money at the time, then don't buy it because you don't have money. All right. And of course, you also have a lot more fees, like here, cancellation processing fee, disbursement fee, processing fee. So you can consider it as one of the other fees. Okay. And also again here, return check fee and so on and so forth. So you really have a lot of fees. All right. Alright, so here are the tips in using your credit card. First tip, you have to pay your bill in full on or before its due date. Because if you do not do that, you will have a lot of charges, okay? And actually, it's also better if before you use that card, you have to know how much you already charged there because you don't want to be surprised when the statement of account comes and then, whoo, I have to pay 25,000 because, it's very deceiving, right? To just, I just swipe and swipe your credit card. The good thing about credit cards now is that you can always check. They have applications, they have apps, mobile apps, wherein you can already check. All right. Next, yeah, I'll just mention it. You have to check your charges every week so that before you swipe that card, you know that, okay, I cannot do this. I already have 13,000 charged on my card. So yeah, it's better not to buy this one if you do not have the money for that. Don't avoid having more than one card, although you can have more than one card, but for me, it's preferable to have one card. I actually used to have three cards, and then there was a time wherein I forgot the due dates of all those three cards, and then I ended up having charges, late charges, and of course, interest charge because I failed to pay it, so I had it cut. All right. Next, of course, don't let someone else charge their spending on your credit card unless you really, really, really trust that person. It's anyway, if he or she is really credit worthy. But for me, for my rule, walang kamag-anak, wala ring kaibig-kaibigan. Okay, next, don't swipe if you don't know how much is already charged to your credit card. So as I have mentioned in the previous slide, you have to know how much is already charged. Okay? Okay. So I have here, the scenario is that you charge 10,000 on your card and then after that, you will no longer charge anything. All right? But instead of paying it in full, you want to pay only 500 pesos every month. If you do not use credit card, how many months will you pay 10,000 for payments of 500? It will only take you 20 months, right? 20 periods, 500 each. But of course, it doesn't work that way because you have to take note of the interest charge. All right. So assumption here is that you have 3.5% per month. So the interest charge, since you did not pay in full, is for this is assuming for your next billing, right? So that's times 3.5. Okay? All right. So you get an interest charge of 350, payment of 500. Okay. Now, what is now your principal? So, it's your previous amount due minus you paid 500 pesos. Correct? So, it's just now 95. But, what will be your amount due? This is for the next month. Okay. What will now be your amount due? So, it will be the principal plus the interest. Is that clear? Okay. Next, then just to show you what's happening again, I will get this one multiply by 0.035, and then again you have your payment of 500. How much is now your principal? It's your amount due, previous amount due, minus of course your payment. But your amount due for this period is the principal plus the interest. Is that clear? Or if you want, since you're using Excel, I just show this row here so that you understand what's happening. You can now just bring this down. And let's see up to 20 payments after 20 months. So after 20 months, oops, I'm sorry. I should change this to yan. Okay, so you can just make copy cells, all right, for that one. So what does that mean? After 20 months, let's see what's happening here. You already paid 10,000, right? But you still have an outstanding balance of 5,758.05. So let us continue this. Let's see how many months you need in order to pay off your 10,000. Let's say up to 30. Still, after 30 months, you still owe 2,195.40. But as you can see, just like in amortization, as time goes by, the interest will get smaller and smaller. And oops, again, there's a mistake here. It should be there, or copy cells. Okay? So see, your interest gets smaller, your interest charge gets smaller and smaller, and most of your payments will now go to your principal. Okay, but still you still owe money. So let's see. There. So here, I need to make this again 500. There you go. So let's change this a little bit so that it's one. Oh, wait, you have here a balance of, that's negative already. So that means, wait, what we should just pay here is your 482 plus your interest so that it will be 0. Is that clear? So that means you have to pay for 35 months. So how much was your total payment? So your total payment was 17,498.90 when you only owe 10,000. So your total interest charge, let's just, of course, that's 7,000, right? So how much is that? That is equal to over your original amount of 10,000. So see, it's 75%. Okay, so from your original loan of 10,000, you have to pay 75% of that loan to your credit card. All right? So if you don't, of course, I just showed you this Excel so that you can also do it. There's actually a website here, practicalmoneyskills.com, and then you can just search practical money skills and then calculator. Let's go there. Practical money skills and then just say calculator. And then this one, financial calculators. Then you go to auto cost of credit. All right, I wait. Credit. How long before my this one? How long before my credit card is paid off? So that one there. So for example, let's do that just to show you that what we did in our Excel is correct. 10,000. And then, interest you pay on this card, this is actually APR. So, since what we have was 3.5% per month, it's actually looking for the annual. So, that's equivalent to 42%. And then, monthly payment of 500. Calculate. Oops, where is that? Results. See, paying 500 per month, you will pay off your credit card in 35 months. And this graph, oops, actually, I want the total principal paid anyway. I want to go to this one. Credit debt. Credit cost. Wait, let's go back. I want to show you how to get the cost of credit. I think this one. This one. It has the credit card APR. So let's do that again. 10,000 and then 42%, 500. Let's see the result. See, number of months to pay off is 35 months. That's the same as what we had here. What else? And then let me this one. Hi, what happened? 10,000, 42, 500. And then here, your final month's payment, that's also the same as what we had earlier. And then this is the total cost. All right? So please be very, very careful and responsible when you use your credit card. If you have a credit card right now and your parents are the one who's paying it, so please be very careful and be very responsible. All right?